Hello everyone and welcome again. So this is what we have so far. I displayed the geometry and the particles, and this is only with 30% of the particles. So if we increase the count, we're going to have way more points, and we need to have enough so that when we render these areas, when we start this, we have enough points to fill those gaps. And it depends on the effects, but overall we need a bit more points to make this feel uh, believable. But overall, I'm pretty happy with how it's looking. We get collision and everything is dissolving as it should be. Now, I do like to show a more advanced collision method with the particles that I showed briefly here with the SDF, but this is not all of it. And um, we'll probably talk about this again, but I want to implement it and show it properly. And I'm going to use this geometry. And what we've done here is simply an approximation, like it's not exactly how this should work. And I'm gonna move over here and let's use a specific frame. So let's freeze the frame, time shift. And I want to show this working in SOPs first and how it actually works, and then we're going to implement it in DOPS and use it. All right, so I'm going to create a bound node. I'm going to convert this into a volume and fill it with points because I want to use this to show what we have. All right, I'm going to use a point VOP. And right now there's points inside and points outside. So if we look here, there should be points inside this SDF and points outside the SDF. And in fact, let me get the SDF that we used here, this one, maybe make it more precise, 0.5, and let's copy this and move it. And this is my second input. And the field is called surface, just in case we needed that. And let's dive inside. I'm going to use a volume sample. And what this node does, it's going to give us a float. And let's just connect it to the color. And this the input is the second input. And if we connect it to the color and display the result, you will see that it has a negative value and a positive value. So that's all we care about. And what that value represents is how far those points are inside this surface, inside that SDF. I'm going to use an if statement. I'm going to use a compare node. I'm going to say if this value is less than 0, I want to do something. And if it's higher than 0, I want to do something else. So the two things I want to do is I'm going to change the color based on the point's location. And I'm going to set this to a vector. It's fine. So it's going to be red if it's inside and just gray if it's outside. I'm going to connect this here and this here. And boom. Right. Let me explain this one more time. So we have a geometry. I made a bound, filled it with points, and I want to test which of these points are inside this SDF, which of these points are outside. The points that are outside, I don't care about them. I'm not going to touch them. They're not colliding with my object. The points inside is what I care about. I want to move them outside. Okay, so how do we move them? Well, remember the gradient idea? So volume sample gradient thing. We're going to do that again. So here, I'm going to connect the position, and I'm going to say the second input, the primitive number is 1. And if I check the normals now, we will see that we have a normal. But this is only represents a direction. And if I normalize this, and what normalize mean is basically you're just going to make sure that the length of this vector is 1. And a normal should always be normalized. So if you have velocity that is higher than 1 and you want to use it for a specific purpose to do some computation, you need to normalize it. This is how you do it. For normal, or if we need just a direction, no magnitude, we can normalize that vector. Okay, so we know how far these points are, right? We got this float here from the sample that tells us how far they are inside. And we'll call it depth. And this depth also has a direction. So what we need to do is we need to normalize this vector and multiply it, because the points that are too far, we want to make them jump higher. We want to make that normal be longer. If they are too close, we want to make it shorter. Okay, so I'm going to use this. I'm going to multiply this vector by this value here. And this is what I'm going to use to offset my points. So I'm going to use an add node and add this result and then plug this into P. And if I look now, you will see that my points have moved. But the move is not correct. Something is not right. And what is not right is the direction of this normal, of this gradient. Right now it's pushing the points inward. And what I need to do is I need to negate it. So I'm going to use a negate node. And then if I put it there, it's going to push all the points to where they should be. Okay, so this is what we need to do, but in DOPS. Okay, we cannot run this here. We can run it on the points. Where is the result? So this one, these points here. So I can copy this. These are my points. And then this is my SDF. And I can check, yeah, this is my SDF. And I'm pushing the points now and coloring them. But I don't need this to happen here. There's no purpose. I need to make this happen inside of DOPS. So let's copy all of this and go back, and let's dive inside and create a pop VOP. And in fact, I'm not going to do it here. I'm going to copy this. I'm going to change a few things. Or actually, let's make just a simple system. Let's make a pop network. And let's create a grid, and this grid is going to be on top of this geometry. Just to keep it simple, I'm going to move it here, scatter points, and I'm going to call this null out temp points. I'm going to copy this again, and I want to use this SDF, the same one that we used. It's not moving or anything. Out temp SDF. Okay, let's go back inside into this new pop. I'm going to create a pop VOP and set the source to all points and use this path. So use parameter value, paste this to be out temp source, I believe, or temp points. Yeah, temp points. And this is going to be easier to see. So if I hit play now, and we put some gravity, obviously, we are going to get points falling down. And I want to have these points interact with that SDF. So merge, and just a plane so we can have them bounce. And now inside the point VOP, I'm going to copy this path and dive inside. And I'm going to say the second input is going to come from a SOP. So when I dive inside, now here, it's going to look up this mapping and give me this data. And let's go to this point VOP and let's copy it all. And I also want to change the color of these points. Let's copy it, paste it here. And the volume is going to be my second input just to be sure it's going to work. And then here it's going to go into my P position. And this is going to be my CD. There's one more thing we have to do, but it's okay for now. So if I hit play, see that the points are moving outside and they are sliding nicely over the surface. All right, so next thing is we don't want this to be happening everywhere. This collision or this add, we want it to only happen when the points are red. So I'm going to copy that two-way switch. I'm going to say if the points are inside, I want to offset them. If they are not outside, I don't want to touch the points. I don't want to move them. And that's my position. So now we are not affecting the other points. We're only affecting the points that are inside. But this is not enough, because you can see once they move, they're stuck forever. So what I'd like to do is I'd like to add some force of this, or the amount that we push the points by, to the velocity. The same thing here, I'm going to use a two-way switch, and then use this amount that we use to offset the position, which goes into this add. And then if this is correct, I want to add it to velocity, or just add this to velocity, because I want to apply that same force back so they're not stuck. If the point is too deep inside, we want to push it away that much from the surface. If it's just here, I want to bounce it back a bit. And so if I hit play now, we should see some interaction. Let me check. Two-way switch, volume sample, and the first input is there. Yeah, this should be working. So let's try here. So I want to add this to my velocity, and then this is going to go outside, and this is going to update the velocity, and I'm going to connect the velocity untouched there. And let's go back up, hit play. Okay, something I need to check this. Something is not behaving as expected. So I'm just, for now, just gonna disconnect P. I don't want to manually offset it. I just want to apply the force needed to move the points away from the surface. And yeah, something is not correct. So let me check this, and then we'll resume in the next video. Thank you guys for watching, and see you in a bit.